In our previous introduction lesson, we have identified role of the data engineer in building the data analytics project. Basically, there are three main tasks data engineer do on day-to-day basis. The first task is extracting the data from various source system and ingesting into the data analytical platform. We called the first layer as ingest layer. The next layer is transforming the source data to find it out useful information. We called it as transform layer, and the final layer is publish layer. The transformed insights are permanently stored in publish layer. In this lesson, we are going to extend with proper source systems that we are going to use in this course, and the Azure Data Analytical Services that we are going to use to build each of these layer, and the list of operations involved in building each of these layer we are going to see in detail. Let us start. There are three different type of source systems we are going to extract the data. The first one is web service, the next one is OLTP database, the third one is third party API, and the data comes from web service is in the delimited file format, and from the database obviously it's in the table format, and from the third party APIs we are going to extract JSON data. Apart from these main source systems, we are also going to extract some open source data. The weather data, it's in the JSON format, and country profile data, something like the GDP growth rate of the each of the countries globally, and that is also in the JSON format. So we are going to build our analytical platform using this source data. We already identified three layers. The first layer is ingest layer, previously we called it. I am expanding little bit logical name because we need to connect to these source systems and we need to ingest the data in the data analytical platform. The next layer we called it as transform. Now I have included integrate also along with transform because we are not getting data from one source systems. From the multiple source systems data is coming. All these data are related data. So need to integrate these data to produce the final output. The last layer is model and publish. Previously we called it as just publish layer. I have included model because we have got standard data modeling techniques to build the data analytics platform, and we are going to learn that as well. Now we need to identify the Azure Data Analytical Service that can help to build each of this layer. If you look at the natural operations happening in this layer, logically we need to connect to the different source system. So we need a service which has got inbuilt connectors for each of the different source systems and extract the data. So Azure Data Factory naturally can fit into this operation, because if you call it as any source systems, Azure Data Factory already got the connector for most of the source system. There are around 100 plus source systems you can connect using Azure Data Factory. And also the different data formats also Data Factory could be able to handle. So Azure Data Factory will be the ideal choice for connecting to the multiple source system and extracting the data. Now Azure Data Factory is a data processing service. It's not a data storage service. It could be able to connect to these different source systems and extract the data, but it can't able to internally store the data. We need the storage service to store the data extracted from the multiple source systems. Again, if you look at the format of the storage service, that need to adapt into store different formats of the data here, because not only one type of the file will come, there will be different type of the data formats will come, and we need a service it can store all the type of the data coming from multiple source systems. For that we are going to use the Azure Data Lake Storage Gen 2 service, because it's file based storage. It could be able to store any type of data in the the same format that is coming from the source. For example, the first one is video file, the next one is JSON file, the compressed zip file and the CSV file, and the last one is different binary file format. So you can able to store any type of the data that is coming from the source systems. So Azure Data Lake storage would be the ideal choice for storing the source data in the same format that we are extracting it. We won't be able to store table data in the table format here, but Azure Data Factory will convert any data coming from the database tables into the files. So again, it will serve the purpose even the data comes from the OLTP databases. Now, these two services are good enough to handle any type of the source system and any type of the source data format. Now we need to find the tool for building this transform and integrate layer. Again, Azure Data Factory has got so many inbuilt transformations here. You think of any transformations against the data. You want to join multiple data sets, you want to union multiple data sets, and you want to look up some data from some of the data set, and you need to derive new columns from the existing data set, and you need to perform some aggregations on top of the source data set. You can able to rank and pivot and unpivot anything you talk about to processing the data. Azure Data Factory has got the inbuilt transformations. So again, Data Factory will be the ideal choice for doing this transform and integrations. So it's not only able to connect to different source system, it can able to transform the source data also into the various formats. Now we will be coming to the third layer, model and publish layer. Again, we need the storage service here because we need to store this transformed data in this layer. So there are two choices we have got. The one is Azure SQL database. We can store the data in the tabular format in this database. We are going to use this one. The another one is the same Azure Data Lake Storage Gen 2. I will explain in detail in which scenario we will use the SQL reporting database and data lake storage. So we are going to use Azure SQL database and the Azure Data Lake storage to build our final data analytical layer. Now, using these technologies, almost all of the tasks that Azure data engineer need to do on daily basis can be done. Now, we are building the data analytical project and it need to be used by set of users after we build it. Okay, if you broadly categorize these users, there are two types of users mainly available for any of the data analytics project. One type of users are called reporting users. They need to know what is happening in the organization and they will build set of reports on top of the data we have built in the data analytics platform. The another one users are the modern artificial intelligence and machine learning services and users. They use this data to build the models to predict the future. Now we will see in detail about what type of data that we are going to use for reporting and what type of source data we are going to use for artificial intelligence and machine learning services. Let us start with reporting. Okay, so we are going to get pricing information data from web surveys. This is the pricing details that we have seen in introduction lesson. We will go in detail about this data again for the time being. So the pricing information, all the pricing information details are coming from the web service in the delimited text format, and we are going to ingest that data into the data analytical platform. Other data that we are going to get it from databases, the master data. It is related to the pricing information, but it's capturing, for example, the market, the different market and market address details it's capturing, and the different country profiles information also we have capturing from this OLTP database. Now these three data sets are good enough to build our reporting platform, and when coming to the reporting, the transformations and the model. There is the existing modeling technique is available. We call it as dimensional data modeling. Okay, if you build your source data in this data modeling format, it can able to serve all the reporting requirements, including new ad hoc reporting requirements. All of the leading industry software providers are recommending to build your reporting model using the dimensional data modeling technique. For our source data, we are going to do the modeling using the dimensional data modeling. As part of the data modeling, the output is creating the reporting database. This data modeling will provide us dimension and fact tables that we need to populate in this transformation layer. So these two layers always work together, because here we are transforming the data to build our final data analytical layer. So in the first requirement is the reporting requirement. We are going to use dimensional data modeling technique to build the reporting database, and as part of the reporting database we need to create the dimension and fact tables, and these dimension and fact tables are the one populated by our data transformations pipeline. There are different type of the dimension tables are there, and the delta records processing is dealing with only processing the new records coming on the daily basis, and we need to run these pipelines on the daily basis. So we need to schedule these transformation pipelines on daily basis. So these all are the tasks involved in building our reporting layer. We are also going to see some performance tuning aspect of the pipelines, and the Power BI is the one of the Microsoft reporting tool that can able to create the reports from the reporting database that we are building in this layer. We are going to show that how we can build the reports using Power BI quickly, so that we can see how the output that we produced here is used in the reporting layer. Now we are coming to build the data analytical platform or Azure AI and machine learning services. These services need additional data on top of our pricing information. We need some additional data, because actually we are building the data that will predict the future of the prices of the products. So we need to identify list of factors that affect the price of the product. So we are going to get additional data from the source systems using the API. One of the data we are going to get is each of the markets involved in this pricing. We are going to get the population data of the each of the market level. This is my hometown, so just I taken that specific data. It's in the JSON format, and once we identified the market profile, then we are going to identify the weather information for each of the markets. Within the 25-kilometer radius, we have got the weather information. It's the open source data, and we are going to get that data also using the API technique in the data factory to get into the data analytical platform. The last data that we are going to get is country profile data. This will give the growth of the different countries, because we are going to identify import and export potential globally using our products. So we are getting that data into the data analytical platform. Now for reporting purpose, there is a data modeling technique called dimensional data modeling. To building the data lake, the type of the modeling they use it called medallion architecture, and we can say data lake design. As part of the data lake design, we need to process semi-structured data. I mentioned semi-structured data processing because all of the data, external data we are getting for building the data lake is in the JSON format. So we need to know how to process semi-structured data using the data factory first before building our data lake final tables. So here we need to integrate multiple data sets, and we need to merge with our pricing data to create the consolidated view about all of the source data that we ingested in the ingestion layer. So as part of the data lake, we used to create bronze, silver and gold tables. So we are going to create the data factory code to populate these tables, and on top of this, in the ingestion layer, we are going to extend our ingestion pipelines to industry ready by creating the metadata driven ingestion pipelines, and also we are making sure that the ingestion pipeline will get the data on daily basis from these source systems. We are going to scheduling it. We are going to use the Azure Data Factory scheduling feature, and the change data capture. This is also interrelated. The day 1 we have extracted all of the data from the source data. In the day 2 we do not need to again extract the day 1 data. We need to only identify the new modified data from the source. That process is called change data capture. It need to happen in each of these layer. Here we are calling it as delta records processing in the transformation layer. This is also same. We insert new data in the ingestion layer, and when processing our transformation code, it need to pick up only the new files coming into the ingestion layer. This is all the major operations we do to build the data analytical platform. On top of this, we need to set up security between these components to make sure the data analytical platform is secure, and also after building entire code, it need to run on day-to-day basis. So we need to have the support systems in place to make sure if any jobs got failed, how to rerun it, and who will look into that one, and who need to be informed. Those type of the operations also we are going to do it. For the security, we need to learn 2 supporting services. One is Microsoft Entra ID, another one is Key Vault. For the operational support, again we are going to learn 2 Azure supporting services, Azure Monitor and Log Analytics Workspace. That almost covers all of the operations that we do in terms of developing the code. Now we need to have the mechanism of controlling the code. We call it as code management or code deployment process. All of the code that we develop, we call it as development environment, and once it tested, we need to move that into the production environment. From there only the end users will be using it. So for that we are going to use Git repo and continuous integration and continuous deployment process. So that covers almost all of the learning that we are going to do in this course. So we have identified the specific source systems. We have identified the Azure Data Analytical Services that we are going to use, and we are going to do specific modeling techniques to build our end data analytics layer. As part of our modeling, there are new set of tables will be created, and we are designing the code to populate those tables. We are building the data analytics platform for reporting purpose as well as machine learning purpose, and we have got process to secure and operationalize our data analytics platform. Also we have got the code management process. So we are going to extend each of these operations one by one, and we are going to see in detail how we will do using these technologies to perform each of these operations, and I will see in the next lesson.